Hello, and welcome to this presentation on solving simple equations. A simple equation is of the form shown here. 2 multiplied by the x plus 1 in brackets is equal to 3x minus 2. We have to rearrange the equation to get x on one side of the equation and all the numbers on the other side. This solves the equation for x. This presentation does assume you're familiar with expansion of brackets, as we'll need that technique within some of the solutions. A simple equation is one that contains the first power of the unknown variable or the quantity. Usually the symbol x is used, but it doesn't have to be x. We could use the symbol y, the symbol t, the symbol theta, etc. Each one of these variables effectively has a 1 against it because it's the first power of the variable we're solving for. So if a simple equation is solved, then there's only one value for the solution, one root as it's sometimes termed. So for example, solving the equation 3x plus 4 is equal to 10, we can rearrange the equation by subtracting 4 from both sides and dividing by 3, and we'll find that x is equal to 2. So one value for x. The mathematical operations required in the solution of these equations vary according to the construction of the original equation. So sometimes we may be required to expand brackets, or add terms to both sides, subtract terms from both sides, multiply terms of both sides, or divide terms both sides. When a solution is obtained, the value can be substituted back into the original equation that we were given in the question to check its validity, as the left-hand side should have the same numerical value as the right-hand side when the value of x is substituted back. In most of the questions you're going to look at, you will have the answers given, so you'll be able to check the answers through that. But it's worth remembering that you can always check a simple equation by back substituting the value of x into the equation and seeing if the left and right hand side balance. In the solution of the simple equations, we're going to use inverse operations to help transpose the equations for the final solution. So don't forget, the inverse operation to addition is subtraction. The inverse operation to subtraction is addition. The inverse operation to multiplication is division. And the inverse operation to division is multiplication. We'll be using this principle in the solution of the equations we're going to look at. Example 1 illustrates the solution of a simple equation. We're given on the left hand side x minus 2, and that's equal to, on the right hand side, 2 multiplied by x minus 4 in the brackets. So again, the solution sequence depends on the original equation. In this particular case, we'll need to expand the brackets, collect the like terms together, and solve. So first of all, removing the brackets on the right hand side, we get x minus 2 on the left hand side is equal to 2x minus 8. Don't forget, we're expanding the brackets here. 2 multiplied by the x and 2 multiplied by the negative 4 is the negative 8. Next, I'm going to bring all the numerical terms onto one side of the equation by adding 2 to each side. So by adding 2 to the left hand side, I will cancel the negative 2, and by adding 2 to the right hand side, I keep the balance of the equation. Simplifying, on the left hand side I get x, on the right hand side I get 2x minus 6. So these two terms have cancelled, and adding the 2 to the negative 8 produces the negative 6. Now I'll bring all the algebraic terms to one side of the equation by subtracting 2x from each side. Don't forget, what we do to one side we do to the other, so now I'm going to subtract 2x from the left hand side and subtract 2x on the right hand side. Obviously this 2x cancels with this negative 2x, and that leaves us with the equation of negative x on the left hand side is equal to a negative 6 on the right hand side. Don't forget, there's a 1 in front of the x we do not write, so that's 1x subtract 2x becomes negative 1x or negative x. Finally, to find the value of x, I'm going to divide both sides by negative 1. To divide in the left hand side by negative 1, I simply get x. Divide the negative 6 by negative 1, I get the value of positive 6. So x in this case is equal to positive 6. And again, don't forget, this term here could be written as negative 1x. Example 1 continued. We now know the value of x is equal to 6 from the previous slide, so I'm going to back substitute the value of x into the original equation and solve and see if the left hand side equals the right hand side. So the original equation was x minus 2 is equal to 2 in brackets x minus 4. So now putting the value of x into the equation, x equal to 6, I put a 6 wherever I get x, and evaluating, I can see on the left hand side I've got 4 and on the right hand side I've got 4. So balance is being maintained here and the answer of x equal to 6 is correct. So x is equal to 6. So that's solution of a simple equation. Example 2 shows another simple equation, but this time it's in fraction format, and fractions usually confuse students. So we're going to take a moment to consider how to deal with fractions in the simple equation. We've got 5x plus 7, all divided by 4. We're subtracting from that 3x minus 8, all divided by 7, and that's equal to x plus 9, all divided by 2. Now when fractions occur in the equation, it's generally preferable to eliminate them if that's possible. Don't forget that the lines denoting the fractions group the terms into single entities. Thus we can introduce brackets as required if it helps us ensure that the terms are treated separately. So below, all I've done here is put brackets around the 5x plus 7 over 4, the 3x minus 8 divided by 7, and the x plus 9 divided by 2. Just a slight formatting change there. Just repeating this line here from the previous slide for convenience. I'm now going to eliminate the fractions. So what I'm going to do now in the solution is to eliminate the fractions by multiplying both sides of the equation throughout by what's called the lowest common multiple of the denominators 4, 7 and 2. So the lowest multiple that these numbers divide into is actually 28. So what I do now is multiply throughout by 28. Notice that every term gets multiplied here by 28. All I do now is cancel down on the next line. So 4 divides into 28 7 times exactly. 7 divides into 28 4 times exactly. And 2 divides into 28 14 times exactly. And that's what we've written on the next line. The 7 multiplied by the 5x plus 7 minus the 4 multiplied by the 3x minus 8 is equal to the 14 multiplied by the x plus 9. On the next line I simply expand the bracket, 7 multiplied by 5x and 7 multiplied by 7, and then the negative 4 multiplied by the 3x and the negative 4 multiplied by the negative 8. On the right hand side 14 multiplied by the x and 14 multiplied by the 9. So expanding the bracket, 7 multiplied by 5x is 35x, 7 multiplied by 7 is plus 49. Now we're subtracting from that 4 multiplied by 3x, that's 12x. And notice negative 4 multiplied by negative 8, so that's positive, 2 negatives make a positive, 32 here. And that's equal on the right hand side, 14x plus 14 multiplied by 9, 126. So now I'm going to collect the like terms together on either side of the equation. In this particular case I think I'll get all the x terms onto the left hand side and all the constants on the right hand side. So looking at the x terms, I've got 35x on the left hand side, and I've got a negative 12x on the left hand side. I've got a 14x on the right hand side, so I'm going to take 14x from both sides, so that will give me negative 14x on the left hand side. Now looking at the constants, on the left hand side I've got a positive 49, so I'm going to subtract 49 from both sides, so that becomes negative 49 on the right hand side, and I've got a positive 32 on the left hand side, so again subtracting that from both sides I'll get negative 32. I'm using my inverse operations here. On the right hand side I've already got the 126, so that remains on the right hand side. Evaluate on the left hand side, 35x subtract 12x subtract 14x is 9x, and on the right hand side 126 subtract 49 subtract 32 is 45. Dividing both sides by 9, x is equal to 5. Example 2 continue, just repeated the original equation here for convenience. We know that x is equal to 5, all we do now is put the value of 5 back into the original equation. So 5 multiplied by x, that's 5 multiplied by 5. 3 multiplied by x, that's 3 multiplied by 5, and x plus 9, that'd be 5 plus 9. So putting the value of x into the original equation, evaluating, we can again see that the left hand side is 7 and the right hand side is 7. So the equation balances, and therefore x is shown to be equal to 5. Here are some tutorial questions. Those of you that think you can solve these without further explanation, I would encourage you to stop the presentation and attempt these questions 1 to 20. The answers are shown on the following slide. Those of you that want further help with the solution of these equations, I undertake some worked examples on later slides. Here are the answers to questions 1 to 20 for your reference. What I will do now on the following slide is work through some of the solutions for questions 1 to 20. Those of you that have completed question 1 to 20, please move on to the next batch of questions later in the presentation. For those of you that might want some further help, I'm now going to solve some of the equations on this slide here. So question 1, we're asked to solve the equation x plus 2 is equal to 7. To get the x on its own, on the left hand side I simply subtract 2 from both sides of the equation. I've got a positive 2 at the moment on the left hand side, so the inverse operation is to subtract. So I'll subtract 2 from both sides. So x in this case will equal to 7 take away 2, or 5. In question 3 here, I'm asked to solve the equation 2 multiplied by q is equal to 4, q being the variable here. So the inverse operation of multiply is divide, so I'm going to divide both sides by 2 to find the value of q. So dividing both sides by 2, I will get q is equal to 4 upon 2, or simply 2. Question 5, I'm given q plus 5 is equal to 2, so to find the value of q I need to subtract 5 from both sides of the equation. So q in this case will equal to 2 subtract 5, so that will equal to negative 3. Question 7, I've got y divided by 2 is equal to 3, so the 2 is dividing the y, so inverse operation is multiply here. So therefore y is equal to 2 multiplied by 3 on the right hand side, or 6. Question 9, 2x plus 5 is equal to 9, so I need to in this case subtract 5 from both sides. So I will get 2x is equal to 4, subtracting 5 from both sides, and now to find x I need to divide by the 2 is multiplying the x, so the inverse operation is divide, so x is equal to 4 divided by 2, or 2. Finally here question 11, 6p minus 7 is equal to 17, p is the variable, so in this case I will start by adding 7 to both sides. So 6p is equal to 24. And now to solve for p, I simply divide both sides by 6. So p in this case is equal to 24 divided by 6. So that's equal to 4. Question 13, we're given 7x plus 12 is equal to 5. So the first thing I will do here in my solution is to subtract 12 from both sides. So 7x is equal to negative 7 in this case. Taking 12 from 5 will be negative 7. So therefore in this case x is equal to negative 7 divided by 7. So negative 1, the solution. Question 15, I've got 14 minus 3x is equal to 8. In this case what I could do, there's several ways of doing this, but I could subtract 14 from both sides. So negative 3x, notice the negative is still there, is equal to negative 6. I'm subtracting 14 from both sides. So therefore x is equal to negative 6 divided by negative 3, which is equal to positive 2. Question 17, I'm given 6m plus 11 is equal to 25 minus 1m. Don't forget there's a 1 there we don't write. So m is the variable this time. So we need to get all the m's onto one side of the equation, and the easiest way here I think is to add one m to both sides, to remove it from the right hand side and bring it to the left hand side. And also I think I could subtract 11 from both sides to get all the constants on the right hand side. So adding 1m to both sides, I will get 7m on the left hand side, and subtract 11 from both sides, I will get 14 on the right hand side. Now dividing both sides by 7, m is equal to 14 divided by 7, which is equal to 2. And question 19, we're given 0.3 multiplied by d is equal to 1.8. Don't forget it's a multiplication. On the left hand side there's no symbol between the number and the variable. We assume multiplication. So it's 0.3 multiplied by d is equal to 1.8. So in this case, to find the value of little d, we simply divide both sides by 0.3. So little d is equal to 1.8 divided by 0.3. And that gives me 6. Here are further tutorial questions, questions 21 through to 30. Again, those of you that think you can attempt them without any more help, I would encourage you to stop the presentation and solve these simple equations. There's obviously more complicated rearrangements involved now, lots of expansion of brackets, collecting terms together. The answers to all the questions 1 through to 30 are shown in the table at the bottom of the slide. If you feel you need further assistance, on the following slides I've worked through some of these questions for your reference. Okay, in question 21 we're given 2 multiplied by x plus 1 in brackets is equal to 8. Now I could expand the brackets here of 2 multiplied by the x and 2 multiplied by the 1, but I don't think I'll do that in this case. What I think I'll do is divide both sides by 2. The 2 is multiplying the brackets, so the inverse operation is divide. So my next line will simply be x plus 1 is equal to 4, dividing both sides by 2. 8 divided by 2 is 4. And then I simply subtract 1 from both sides of the equation. So x in this case would equal to 3. Question 23, I've got 2 brackets here. I think I will expand the brackets this time. So I'll be multiplying the 3 by the x and the 3 by the negative 1. And then negative 4 multiplied by the 2x and negative 4 multiplied by the 3. So the next line will give me 3x minus 3 minus 8x minus 12 is equal to 14. Notice here the negative 4 multiplied by the positive 3 is given a negative 12. Collating my like terms on the left hand side, 3x minus 8x, that's negative 5x, and then negative 3 take away the 12 is negative 15. On the right hand side I've still got the 14. Now I'll add 15 to both sides of the equation. So my next line I will get negative 5x is equal to positive 29, that's adding 15 to the 14. And then finally to find x, I will divide both sides by the negative 5, so 29 divided by negative 5. We usually write the negatives on the top line, so really that should be negative 29 divided by 5. Question 24, again I've got brackets to expand, so I will expand my 5 multiplied by x and my 5 multiplied by the positive 2, and then negative 3 multiplied by the x and negative 3 multiplied by the negative 5. Be careful there, the sign change. So my next line will be 5x plus 10 minus 3x plus 15 is equal to 29. And be careful of the change in sign. We've got a double negative. Negative 3 multiplied by negative 5 is positive 15. Relating my like terms together on the left hand side, 5x minus 3x will be positive 2x, and positive 10 add my 15, that's positive 25. That's still equal to 29. Now subtracting 25 from both sides of the equation, 2x is equal to 4, 29 take away 25 is 4. Dividing both sides by 2 now to find the value of x. X in this case is 2. And again, you can check that by putting the value of x back into the equation given. So question 27, we're given x upon 5 minus x upon 3 is equal to 2. You can think of that 2 upon 1 if that helps you. What I think I would do here is multiply throughout by 15, because 5 divides completely into 15 and 3 divides into 15. So multiplying both terms by 15, I will get 15x divided by 5 minus 15x divided by 3 is equal to 30 on the right hand side. I multiply throughout every term, left and right hand side multiplied by 15. We can see there's some cancelling here. The 5 divides into the 15 3 times, and the 3 divides into the 15 5 times. So my next line would be 3x minus 5x is equal to 30. So my fractions now have disappeared. Bringing my like terms together, 3x minus 5x is negative 2x, and that's equal to 30. So therefore x is equal to 30 divided by negative 2, which is equal to negative 15. Question 29, again we've got fractions to deal with, and again if it helps you, that's 3 upon 1 and that's 2 upon 1, the fraction format. What I think I would do here is multiply throughout by 6, because 2, 3 and 6 divide completely into 6, it's the lowest common multiple, and that will remove the fractions. So multiplying throughout by 6, I will get 6m divided by 2 plus 6m divided by 3 plus 18, 6 times 3 is 18, and that's equal to 12, 6 times 2 is 12, plus 6m divided by 6. I've labelled that just to show the process involved here. What we can now do is cancel top and bottom, so 2 divides into 6 3 times, 3 divides into 6 twice, 6 divides into 6 once. So my next line I could write 3m plus 2m plus 18 on the left hand side is equal to 12 plus 1m, or simply m on the right hand side. Collating my m terms together, on the left hand side I would have 5m plus 18, the constant, is equal to 12 plus m on the right hand side. So now subtracting 1m from both sides of the equation and subtracting 18 from both sides of the equation, I'll be left with 4m on the left hand side, that's 5m take away the 1m, and on the right hand side I'll be left with negative 6, that will be 12 subtract the 18. So in this case m is equal to the negative 6 divided by 4, or negative 3 upon 2. If you want that in decimals, of course, that would be equal to negative 1.5. Tutorial questions continue. This is question 31 through to question 44. Again, if you feel you can attempt these questions without further assistance, I would encourage you to stop the presentation now and attempt questions 31 to 44. The answers are shown on the following slide. If you want further help, then I will work through some of these solutions on later slides. Here are the answers for questions 31 through to question 44. Here are some word solutions for some of the questions. Question 33, 4 divided by t is equal to 2 divided by 3. Now we can, in this case, if we want to, we could turn both sides of the equation upside down, so have t upon 4 is equal to 3 upon 2, but you need to be careful sometimes in turning equations upside down. Not all equations can be turned upside down. So what I'm going to do here is multiply both sides by t to get the t on the top line, and multiply both sides by 3. So my first line here would be 12 on the left hand side is equal to 2 multiplied by t on the right hand side. So that's multiplying both sides by t. The t counts on the left hand side and crops up on the right hand side. And I'm multiplying both sides by 3, so the 3 counts on the right hand side and it crops up on the left hand side as 3 times 4. To find the value of t, we simply divide both sides by 2, so 12 divided by 2 is 6. 6 is equal to t. We just turn the equation around to have the subject on the left hand side, so t is equal to 6 in this case. In question 35 we're given 4 upon 7 multiplied by y. minus 3 upon 5 multiplied by y is equal to 2. Sometimes it helps to perhaps rewrite that as 4y upon 7 minus 3y upon 5 is equal to 2. It's the same equation, but sometimes students understand it more clearly when the y's are written on the top line. That's what it means here. What I think I would do here is multiply throughout by 35. 7 and 5 divide completely into 35, the lowest common multiple here, and that will remove the fractions. So multiplying both sides by the 35, I will get 35 multiplied by 4y in the bracket there divided by 7. Multiplying the next term by 35, that's 35 multiplied by 3y in the bracket divided by 5. And don't forget, I must multiply the right hand side by 35, so that becomes 70. Cancelling down, 7's into 35 goes 5 times, and 5 goes into 35 7 times. So my next line, I will get 5 times 4 is 20y minus 7 times 3 is 21y is equal to 70. So 20y subtract 21y will give me negative 1y or negative y, and that's equal to 70. So therefore in this case y is equal to negative 70. Question 39, 2m minus 3 upon 4 is equal to 4 minus 5m upon 3. And again, if you want to, we can think of that being in brackets on the top line here to make it easier to follow. What I think I would do here is multiply both sides by 12, which is the lowest common multiple for 4 and 3. 4 times 3 is 12, and that will remove the fractions from the solution. So multiplying the left hand side by 12, that becomes 12 multiplied by in brackets 2m minus 3, that's all divided by 4 still, and on the right hand side that will be 12 multiplied by 4 minus 5m in the bracket, and that's all divided by 3. So I've not affected the equation, I multiplied both sides of the equation by 12. On the next line we'll find that 4 divides into 12 3 times, and 3 divides into 12 4 times, so I can now write 3 multiplied by 2m minus 3 in the bracket, and that's equal to 4 multiplied by 4 minus 5m in the bracket. Expanding the brackets on the next line, I will get 3 times 2m, that's 6m, and 3 times a negative 3, that's negative 9 on the left hand side, and on the right hand side 4 multiplied by 4, that's 16, and 4 multiplied by negative 5, that's negative 20m. On the next line, collecting all my m terms on the left hand side and my constants on the right, I'm going to add 20m to both sides, so that will give me 26m on the left hand side of the equation, and I'm going to add 9 to both sides of the equation, that will give me 25 on the right hand side of the equation. 16 plus my 9 is 25. Dividing both sides by 26, m in this case is 25 divided by 26. Question 43, I've got fraction formats with my x in the bottom lines again, so I'll put my brackets around the fractions to help me understand the format of the equation. And what I would do here is multiply both sides by x minus 2, multiply both sides by x plus 4, and that will remove the fractions. So my next line, I will get 3 in brackets x plus 4, that's multiplying both sides by the x plus 4, and then multiply both sides by the x minus 2, that will equal to 4 x minus 2. Think that through for yourself how we did that. Basically what we're doing is multiplying both sides by the x plus 4, so the x plus 4 counts on the right hand side but it appears on the left hand side in the top line. Then multiply both sides by x minus 2, so it cancels from the left hand side but it appears on the top line on the right hand side. So now expanding the brackets in the conventional way. Left hand side I will get 3 multiplied by x plus 12. On the right hand side I will get 4x minus 8. Now collecting my terms together, if I subtract 4x from both sides of the equation I'll get negative x on the left hand side, and if I subtract 12 from both sides of the equation I'll get negative 20 on the right hand side. Negative 8 take away 12 is negative 20. So therefore we can clearly see that x is equal to positive 20. And here are the final batch of questions for those that want to attempt these on their own. Question 45 through to 50. The answers are given at the bottom of the slide here. I'd encourage you to stop the presentation and attempt these questions if you feel you can. If not, the work solutions to some of the questions are shown on the following slides. Question 47 is quite complicated here. We've got three fractions, and again I'll put brackets around the numerators to show how they're separated. What I think I would do here is simply multiply throughout by 12, because 3, 2 and 4 will divide completely into 12, so that's the lowest common multiple, and that will remove the fractions. So on the next line I will get 12 multiplied by brackets 4p minus 1, that's all divided by 3, and we'll subtract from that 12 multiplied by the 3p minus 1 in the bracket, all divided by 2, and on the right hand side that's equal to 12 multiplied by 5 minus 2p, and that's all divided by 4. Don't forget we're multiplying throughout by 12, so every term gets multiplied by 12 here. Cancelling down, 3's into 12 will go 4, and 2's into 12 will go 6, 4's into 12 will go 3, so on my next line I will have 4, and in brackets 4p minus 1, and I subtract from that 6, in brackets 3p minus 1, and that's equal to, on the right hand side, 3 in brackets 5 minus 2p. Expanding my brackets, that will now be 16p minus 4 minus 18p plus 6, be careful they're the double negatives, and that's equal to, on the right hand side, 15 minus 6p. So again, be careful of the double negatives that occur sometimes. Double negatives here will give me the positive 6 here. Collecting my terms together, on the left hand side I've got 16p, and we subtract from that 18p, so that becomes negative 2p, and I've got negative 4 plus 6, so that's plus 2 on the left hand side. On the right hand side I've still got 15 minus my 6p. Now bringing the p's to the right hand side, if I add 6 to both sides of the equation I will get 4p on the left hand side, and if I subtract 2 from both sides of the equation I will get 13 on the right hand side. Dividing both sides by 4, then p is equal to 13 divided by 4. In question 49, x divided by 3 minus, and again I can put brackets around here if I want to, the 2x minus 5 all divided by 2 is equal to 0 on the right hand side here. Again I will multiply throughout by the lowest common multiple, which is 6 in this case, so on my next line I will get 6x divided by 3 minus 6 multiplied by 2x minus 5 all divided by 2, and of course 6 times 0 is still 0. Cancelling down, my 3 goes into 6 twice, and my 2 divides into 6 3 times, so my next line I will get 2x minus 3 in brackets 2x minus 5, and that's all equal to 0. Expanding the brackets, 2x minus 6x plus 15, double negative there, is equal to 0. 2x minus 6x is negative 4x, and that's equal to negative 15 if I subtract 15 from both sides of the equation. So therefore x is equal to 15 divided by 4. And finally we're going to look at some descriptive questions on worksheet 2 here. These require very simple solution processes, but the first thing we've got to do is to actually find the simple equation, because it's tucked away in the question. Again, those of you that think you can attempt these questions without further assistance, please feel free to stop the presentation and attempt the questions now. The solutions to all of the questions are shown in the brackets on the right hand side. But those of you that feel you need further assistance, then the solution to the first 4 questions here are shown on the following slides. Okay, in question 1 we're given a team leader and 5 workers together earn £732 in a day. We're told that the team leader earns £12 per day more than each of the workers. We've got to find how much earn the team leader and the workers. So first of all we need to generate the equation. So if I use some notation here, if I say T is equal to my team leader and W is equal to a worker, then reading the question I can write an equation that 1T, one team leader, plus 5 workers, 5W, is equal to £732. So one team leader plus 5 workers earns £732 in the day. I'm also given another relationship that the team leader earns £12 per day more than each worker. So my second relationship could be T is equal to 12 plus W. In other words, the team leader is earning £12 more than the worker. If I now take the expression for T is equal to 12 plus W and put it into the original equation, I'll be able to solve for W because I've generated a simple equation. So on the next line I've basically got 12 plus W plus 5W is equal to 732. So what I've done here is replace the value of T with the 12 plus W here. Now I have a simple equation. I don't actually need the brackets here. That's simply 12 plus W plus 5W is equal to 732. Bringing my W's together, that becomes 12 plus 6W is equal to 732. And if I subtract 12 from both sides of the equation, I end up with 6W is equal to 720. Dividing both sides by 6, and W equals 720, divided by 6, which equals to 120 pounds. So a worker earns 120 pounds. Going back to my original equation here of T is equal to 12 plus W, I can now find what the team leader earns, and the team leader earns 12 plus the 120, so 132 pounds. So hence question 2, we're told that one side of a triangle is 4 meters longer and another 3 meters longer than the shortest side of the triangle. We're told that the triangle's perimeter, all 3 sides added up, is 25 meters. We've got to find the length of all 3 sides. So sketching a simple triangle, say something like this. Not quite sure what a triangle looks like. We'll let x equals to the shortest side of the triangle. So if I call this side x here, I'm then told another side of the triangle is 4 meters longer than x. So if I call this x plus 4, another side is 3 meters longer than x. That's x plus 3 here. There's my sketch of the information from the question. Now we know that the perimeter, P, is equal to 25 meters. So in this case, when I add up all the 3 sides, it must equal to 25 meters. So 25 must equal to, looking at my sides, I've got a side length x. I'm adding to that, I'll put it in brackets for clarity, the side of x plus 4. Don't need the bracket here, but I'll put it in for clarity, and then the side of x plus 3. So adding all 3 sides up, it must equal to the perimeter of 25 meters. As I said, I do not really need the brackets here on the right hand side, so I can simply write that as x plus 4 plus x plus 3. There's a positive outside each of the brackets, so I didn't need the brackets in this particular case. Bringing my like terms together on the right hand side, 25 on the left hand side is equal to 1x plus another 1x plus another 1x, so that's 3x, and adding my constants together, 4 plus 3 is 7, so 3x plus 7 on the right hand side. Subtracting 7 from both sides of the equation, I end up with 18 is equal to 3x, so therefore I can see that x is equal to 18 divided by 3. which is equal to 6, in this case meters. So now the shortest side is 6, I can now find the other two sides. So the side lengths are 6 meters. We've got then 6 plus 3, which is 9 meters, and we've got 6 plus 4, which is 10 meters. So those are our three side lengths in this particular case. In question 3, we're given three angles of a triangle. We're given as x, x plus 30, and x minus 6. That's in degrees. We know that the sum of the three internal angles of a triangle add up to 180 degrees. We've got to find each of the angles. So again, making a quick sketch of our triangle, say something like this. If this is angle x given in the question, then this could be x plus 30 over here, and this would be here x minus 6. So knowing that the three internal angles add up to 180 degrees, we can now generate a simple equation in terms of x. So 180 degrees will equal to x plus, again I'll put them in brackets for clarity, x minus 6 plus x plus 30. I do not need the brackets here because it's positive outside, but just to show the three sides on the right hand side. So I could simply write that as 180 degrees is equal to x plus x minus 6, I don't need the brackets, plus x plus 30. I basically have three x's here. I've got 1x, a 1x and a 1x. So 180 degrees on the left hand side is equal to, on the right hand side, 3x, adding my x's together, and I got minus 6 plus 30, so that's plus 24. Subtracting 24 from both sides of the equation, I will now get 156 degrees on the left hand side is equal to 3x. Therefore the x is equal to 156 degrees divided by 3. This gives me a value of 52 degrees. Thus our three angles. So 52 degrees from our calculations. Adding 30 degrees to that, that's going to be 82 degrees. And subtracting 6 from 52, that will give us a value of 46 degrees. So those are our three angles for this particular triangle, given the parameters in the question. In question 4, we're told the perimeter of a rectangle is 56 millimeters. So adding all four sides up, we get 56 millimeters. If one of the two adjacent sides is 8 millimeters longer than the other, we've got to find the dimensions of the rectangle. So if I sketch a rectangle here, and if I call in this case the shortest side x over here, so we've got an x and an x here, and we know that the other side is 8 millimeters longer, so this would be x plus 8 millimeters, this would be x plus 8 millimeters. We know the total perimeter is 56 millimeters. So in this case then 56 will equal to, adding the four sides, we'll get x plus an x, that's the two short sides, and we're adding to that the x plus 8, and adding to that the x plus 8 to label the equation. That's a simple equation in terms of x. Simplifying on the next line, that becomes 56 is equal to x plus x plus x plus x, that's 4x, and we've got 8 plus 8 is 16. Rearranging the equation, subtract 16 from both sides, that will give us 40 is equal to 4x, and then dividing both sides by 4, x is equal to 10 millimeters. Thus, the sides of the rectangle are 10 millimeters by, and then adding 8 to the 10 would be 18 millimeters. I'll leave you with some further tutorial questions, questions 5 through to 7, the descriptive questions. Read the questions carefully, extract the information from the question, draw diagrams where appropriate, and generate the simple equation from the information given. Be careful with question 6, the way it's worded. It's quite a confusing question, so read the question very carefully. Use a sketch to help you break down the problem. And finally, questions 8 through to 10 for you to attempt. They all relate to simple equation problems. Here's a bibliography used to help generate the presentations. A very good textbooks here for technician engineers. I hope this has been of interest to you, and thank you for viewing.